Hello, everyone, and welcome to today's webinar on data-centric strategies to break the cycle of legacy addiction. In the next hour, we'll explore where semantics, knowledge graphs, and data-centric architectures can play a role helping organizations move away from legacy data silos. Now, I will introduce our two experts today. Dave McComb is the president and co-founder of Semantic Arts. He and his team help organizations uncover the meaning in the data from their information systems. Dave is also the author of The Data-Centric Revolution, Software Wasteland, and Semantics in Business Systems. For 20 years, Semantic Arts has helped firms of all sizes in this endeavor, including Procter & Gamble, Goldman Sachs, Schneider Electric, LexisNexis, Dun & Bradstreet, and Morgan Stanley. Prior to Semantic Arts, Dave co-founded Velocity Healthcare, where he developed and patented the first fully model-driven architecture. And prior to that, he was part of the problem. That was in Dave's bio. I didn't write that. Brian Platz is the co-founder and CEO of Fluree, an open-source knowledge graph database built on JSON, LD, and W3C standards. Brian has decades of experience building enterprise software. He is now devoted to the data-centric movement, helping organizations build decentralized, interoperable data ecosystems. And with those bios out of the way, we are ready to get started. Dave, you can take the wheel from here.
Great. Thanks, Kevin. So everybody's noticed the data is exploding, and you can get a bazillion graphs here. This one claims that we're now producing 40 zettabytes, whatever those are, per year. And, it's up from, just 10 years ago, it was barely more than one. So we're 40-fold explosion, and 10 years before that, another 40-fold, et cetera, et cetera. And at some level, we've just convinced ourselves that this volume of data is so massive and there's so much, and we have to manage it. And what would sensible people do to manage that amount of data? And it turns out what sensible people mostly do is divide and conquer. They say there's so much data, we couldn't possibly get our heads around it. And so we're going to have an expert in each little piece of the data puzzle that we have here. And, just to give you an idea, most enterprises now have hundreds, some have thousands of data stewards and data governor people, data governance people. And that's almost entirely because each one has, here's my puzzle piece, and this one looks like a red door with a gargoyle, and how can I contribute to the overall goodness of my firm? And what this kind of ends up looking like over time is that every once in a while, almost by happen chance, it seems, I fit two pieces together. Look at that. I get a merit badge or something for this, and we call this systems integration. But we don't stop to back up and say, how did we get in this incredible fractionated landscape anyway? So that's what we're going to be talking about today. But in order to kind of get our heads around what the opposite end, I suppose, of this spectrum, if at one level we've got all these puzzle piece parts and we're just wandering around trying to stitch a couple of them together and calling that systems integration, what's the opposite of that look like? What I would suggest is what is literally going on in most of the enterprises we wander into is people are trying to put this puzzle together and they lost the lid of the box. We have no idea what the overall picture looks like, and therefore, every time you pick up a random piece, it's like, whoa, you got anything that looks sort of like this? And just because I happen to have this puzzle piece metaphor going, and I hope people aren't too tired of Minnesota jokes, Sven and Ole jokes. So Sven and Ole go into a bar, and Ole says, "Hey, bartender, set up a round of drinks. It's on us. Sven and I have just completed our first jigsaw puzzle, and it only took us 3 months." The bartender starts setting up. He says, I'm happy to set up the drinks for you boys, but 3 months, God, it sounds like a long time for a jigsaw puzzle. Sven says, are you kidding? The box said 4 to 6 years. Anyway, here's what a rough approximation of what the top of the box, the jigsaw puzzle box lid looks like in most enterprises. And I'm saying this because we've done this almost 100 times now. And while this looks kind of simplistic, this is my Jeopardy analogy. These aren't just categorical or domains or anything like that. These are every box here has instances of real world data, nodes in a knowledge graph. But let's drill in just a little bit to get a slightly better idea. The idea is that this should cover, and I think it does in most cases, almost all the data, structured and unstructured, that you find in your enterprise. Now, you're going to want a little bit more detail than this. 28 concepts may sound a bit on the light side. So, for instance, depending on the industry you're in, you will have different kinds of people. So you'll have subclasses of people. You'll have employees. You have ex-employees. You are selling things. You may have leads. Some of your leads actually may be ex-employees. That happens all the time, but people don't have a way to represent or recognize that. You have sponsors in your clients. If you're in healthcare, you've got patients and providers. If you're in insurance, you've got claimants and, agents, all that kind of stuff. Each one of these boxes typically has another 5 to 15 subclasses, but almost all the information data you're going to find is covered by this set of concepts. Where did it come from? It looks so simplistic. It actually came from some things that are much more geeky. We have ontologies and we have axioms and we have ways of formally communicating what things really mean. And we draw, boxes and arrows and UML looking diagrams and stuff. But the truth is, if you want to show this to an executive, and if you want business analysts to find their way through it, I think we need something a bit simpler. We need to bubble it up, boil it down, whatever you call it. But so earlier, when I had person on the Jeopardy board, it really is somewhere in a hierarchy of concepts, and we can map directly to this. So we think this is pretty close here. This set we're starting with, we certainly start there. Why do we have daily doubles on there other than the Jeopardy analogy? It's because, let's assume there's a couple of things in your industry or your business that we've overlooked. There's a place for a few more top level concepts. But really, this view is just the tip of the iceberg. This is just the T box, as we call it in ontology. This is the schema. This is the description of the types of things there are. But if you were to look underneath this, there's actual real data. Those little diamonds there represent each one's a person. This person reports to this other person. This person is in this organization. This person is badged to this building. This person, that's the knowledge graph is underneath this, connected, but really completely discoverable and described from this top level view here. Now you may be thinking, going back to the data explosion, the world is exploding with data. What am I going to do? There's some data that just for the sheer volume, the infrequency of access and its up to dateness, you're going to say, let's leave it out there in the historian, or let's, on the edges, if you will. But even in that case, we advocate, there's open source standards for mapping. For instance, in this case, running software, we can query from this backplane and reach into very large data sets at runtime, just bringing back the handful of data that's actually important for your query. So, a lot of the end game is kind of the balancing act. What percent of the volume of your enterprise data do you want co-located and represented in the graph, easily and rapidly queryable? And what do you want mapped, but still available at runtime. So to put a little more perspective, I was just giving a presentation last week at AASHTO, and it reminded me of this project we did quite a while ago for the Washington Department of Transportation, where we drew a picture. This is a 20-foot long diagram that's 6 feet high, and it had a box for every one of the systems that we'd found. Actually, over time, we found more and drew more lines. But the point I wanted to make, when you stare at a diagram like this, and everybody has a diagram like this if they choose to draw it, and every line there is a bespoke, handcrafted piece of integration. And by the way, this diagram gives you kind of a graphic idea of why legacy modernization is hard. Because if you take any one of those boxes and say, I'm going to replace it, you're going to rip it out and put a new, not so legacy version in there, you have two incredibly hard problems. The first one is that finding another application that covers exactly the same functionality as the one you took out is actually pretty hard. These things evolve the shape they have because they're in the environment they're in. And the other is, it's a lot like open heart surgery or heart transplants. You know, it's pretty easy to take somebody's heart out, and it's pretty easy to put a new heart in. But what's really hard is getting all this stuff wired up before they die. You know, all the veins and arteries and nerves and all that stuff. Anyway, that's just kind of an aside about what people are typically facing, what they're looking at, and what we're trying to get them past. But I hope when people look at a diagram like this, that they see it kind of the way I see it, which is every box on this diagram is its own application and therefore has its own database, which has its own schema, which consists of hundreds or sometimes thousands of tables, each of which has dozens and dozens of attributes. Every little can on this diagram is a world unto itself. Its own language, its own terms, its own level of abstraction, its own structure, its own joins. You know, it's just, when you finally get your head around this, it's, you know, no wonder people are just picking up puzzle parts and wandering around with them and say, oh, I think I've got some clinical data here or something. So that's the current state. That's not really the necessarily the desired end state, but we're gonna get to that. I want to say a few more words about how to get beyond that. One is to say that there, despite the fact that picture I just showed you had probably had about 500 databases, each of which was quite complex, and then if you multiply that all out, there are millions of data distinctions represented just in that one organization. And yet at the opposite end of that Jeopardy board I had suggested, well, there's really 28. And if you blow it out, there's about 500 typically concepts with a few thousand taxonomic categorical distinctions that don't actually affect the structure of the thing. They just affect some of the fine-grained distinction. So that's one side of solving the problem, is finding the box top, understanding what the picture looks like that we're trying to find the pieces for. The other side, and I'm just going to touch on it briefly here, is also that picture I just showed, and there have been many, many studies about this. Every time you add a new attribute to a traditional system, you add several thousand more lines of code, because that attribute has to be moved out of the database, put into an API, put into a transaction, moved over into the DOM, and, you know, reflected onto the screen and validated. And so every single one of those millions of data distinctions is dragging along thousands of lines of software code, all of which are full of bugs. Even clean room software has something like 10 undiscovered defects per 1,000 lines of code. So you're just waltzing around with this time bomb. We're also getting deeply into cybersecurity now, and the more of these things you have, the bigger your surface area for for being attacked. So the thing, there's millions of reasons to get beyond this. And part of getting beyond this is the model-driven approach. So in a typical enterprise system, there's data in a database, very typically in a relational structure. There is code that reads that data, moves it around, does something with it. Sometimes there's two or three, there's the server side and the client side, or the, web tier, wherever it is. There is code that is moving that data into the right field on the form and doing all that kind of stuff, validating, et cetera, et cetera. So that's what a typical application looks like. So therefore, if you have not just several databases, but every use case is another chunk of code. Every database repeats this again until you have, an amazing number of systems. And everybody just accepts this. Oh, we're going to have a new system. Maybe we can buy it. Maybe we can software as a service it. Or maybe we have to build it. And if we build it, we're writing more code. But let's look at the alternative to that. The alternative, if you stare really hard at these things, which I've done many, many times, you realize, man, 90% of these use cases are not really all that different. They're a bunch of forms, cards, tables that just are slightly different because this one has 4 fields and this one has 2, and these 2 fields have to be validated together. We have to compare. There's some cross-field validation, but really that's about it. So conceptually, you can write one piece of code. It's a piece of architectural code that we have over here on the right now, and just describe what the use case is in data. And in this case, the data looks like a graph because we think that's the preferred way to do it. There's lots of companies out there that have done this with relational. There's OutSystems and Mendix and several of them like that. But we think the best practice is not only to represent your data in a graph, to represent your application in a graph. And by the way, these are pretty small graphs. It doesn't take a lot to describe most use cases. And then one piece of code that just interprets that graph and generates the user interface. And when somebody fills it in, same piece of code, takes the now triplified little bits of data, runs them by yet another model, a shackle style model that will validate this and persist to the database. Gartner calls this low code, no code. We kind of like the term model driven better, but it's all part of the same movement, really. So I wanted to kind of, at a very high level, draw how dire the existing situation is and what's possible. We know both of these things with a great deal of certainty. The tricky bit is getting in between. You got to get from point A to point B to make any progress here. So we're going to talk about next. This is just kind of recreating what we see all the time. We call it legacy redoubling. Every time somebody has a business problem, they wake up, we have a problem. Oh, it's an information systems problem. We need an application to solve this. Let's go build, buy, or nowadays rent through software as a service. Let's go solve this problem. So they launch a project and on you go. But what they kind of discount is in the act of solving the problem and the local improvement, we actually globally make things worse. We've just gone from 1,000 databases to 1,001. Doesn't sound like a lot, but it adds up. But it's not like people don't notice that they're doing this. Every once in a while, somebody wakes up and says, wait a minute, how come we have 40 inventory control systems? That's like 39 more than we really need. Yeah, I know, but this is different. This one came from an acquisition, and this, blah, blah. Some of these are very, we worked for a medium-sized company. It was a workers' compensation insurance company, 3,000 people, not gigantic. And they discovered that they'd accidentally implemented what they would later realize was accounts receivable functionality, but it didn't feel like accounts receivable because, here claims over payment, they were trying to get back the money the claimants had kept, or here it was elevator permits, they needed to get paid for the permit. So every one of them had its own local language that kind of obscures the fact that, no, you do have 23 invoicing and accounts receivable systems with different names scattered all over the place. And yeah, no kidding, you have a problem with revenue recognition. But anyway, every once in a while, somebody wakes up and says, wow, we have way more applications than we need. Let's do some legacy rationalization. Let's try and take this from 5,000 systems down to 4,000. That'll be great progress. And they will launch a project that goes on for several years. It's harder than it sounds, partly because of that spaghetti diagram we had. Every one of the existing applications is already interfaced in all these points, and you got to move this one, and everybody ends up deciding they're going to rationalize around the most complex apps they have, which also makes it harder. But anyway, they do that, they make some progress, but almost as soon as they've gotten it from 5,000 down to 4,000, somebody comes along and starts adding more to it, and in a few more years or in a decade, they'll be back at 5,000. So that's the hamster wheel, if you will, that most enterprises are currently on. Here's kind of the alternative. And we sort of stumbled into this just by observing what was happening. There's this other path. It's a journey, and it starts almost everybody. We don't recommend people doing a proof of concept because they're too abstract, and sponsors don't understand what they just saw. A pilot is doing enough of a project with real data, solving a problem that's not currently solved, to where a sponsor, when they look and recognize their own data, they go, oh, that's what you meant. So that next little, and they're typically smallish projects, and the next couple of projects are typically smallish. It's just kind of expanding the footprint. Let's gather some more data from some more areas, get more data in the graph, and let's start working with it. And at that point, still, for most people, it looks like a slightly better data warehouse, and slightly better because it's more interrelated. It's got the rich relationships. You can do graph analytics. There's a lot of benefit, even on that skinny part of the arrow. But where it gets really interesting, that next chunk there, we've just started to notice that some of our clients, they get to a certain amount of data in their knowledge graph, and they go, I'm starting to see where this is going. We were about to stand up a new project to solve problem X, problem of the year, but maybe we should pause. Maybe we should see. Maybe we can solve that without building another database, another standalone app. So often we're seeing this phase we call legacy avoidance. Just quit digging the hole any deeper. And then there's another phase where people realize, unlike a traditional data warehouse, these systems, you can build use cases to directly update. You can implement transactions, you can implement use cases, you can implement functionality. And people typically will implement, some small, low volume. They're still experimenting. We're learning how to do this, but will, in fact, do some of these use cases. And then they go, wait a minute. Right now, in a traditional data warehouse, the people don't notice this, but the data warehouse is keeping us locked into legacy because the data warehouse has to get fed from the legacy system. If you take the legacy system away, the data warehouse becomes empty and nothing works. But in this world, you say, wait a minute, if I can do an interface here, I was doing the use case in legacy systems, going to the legacy database, going through a pipeline, it's ending up in the graph. But now I say, wait a minute, I can just do the use case directly here, and then I can quit using that part of the legacy system. I don't have to decommission the whole thing. I don't have to worry about all its integration points. I can just take out a few use cases. And that's what we call a legacy erosion, just taking functionality away from your legacy system a little bit at a time until finally you get enough nerve, I think it is, to say, we've got all the data here, and we've got a way to build use cases, which might be model-driven, it might be bespoke. It really doesn't matter. It's just more efficient to do them model-driven. I now am in a position where when that legacy system is at the end of its life, instead of replacing it with the neo legacy version of the same thing, say, let's just do it right here in the graph, since we're here anyway. So with that, I'm going to turn it over to Brian. I'm going to be available for color commentary here, but take it away, Brian.
Thanks, Dave. I really appreciate it. I guess we've had an opportunity to do a few presentations together now, and I always continue to have some light bulbs go off when I listen to you. And of course, you inject some new humor into these every once in a while, so always get a couple laughs too. Just to remind everybody, we are going to have a little bit of time for some questions if they come up. So we have, there's a question section in the webinar, and there's a chat section. I think either is probably fine, but Kevin will lead us through that after we finish here in about 15 or so minutes. So as they come up, please go ahead and type, and we'll get to those. I'm going to go over a little bit on what Dave talked about and kind of transition into how technology solutions end up solving some of these challenges, or kind of putting it more into that context. So how do we put some of this into practice in a short amount of time? I'll start out by kind of rehashing what Dave just finished off with on that data-centric journey and kind of these stages. The first being this legacy amplification stage. And this is where, as Dave has described, we have all of these apps. The third tier of the app is the data. And the data has no smarts. It's not intelligent data. We often use the term inert data because the intelligence around the data actually exists in custom code in the app. And, we need, of course, this data for lots of uses today outside of the app. Might be analytics to improve customer support. It might be, analytics or data consolidation to make a supply chain more efficient. And of course, we have LLMs now and artificial intelligence that can have some really significant advantages to organizations. But without good data, of course, it's limited in usefulness. Most organizations, I don't think, are in a good position to really take advantage of these technologies. And, our view is that, or it will be critical for most organizations' survival in the coming years to be able to do that. And that's because we think most companies will figure it out, and those that don't figure it out will have a difficult time competing. So we have to do this. We're doing it today, but we're doing it via kind of a Band-Aid approach. We're copying and pasting, literally copying and pasting data out of the back end of these apps into a data warehouse. This copied and pasted data is inert, right? It has no intelligence in it. We sort of left that with the app. It has no permissions or policy in it. We left that with the app. So then in order to use it properly, we have to rebuild all of that logic in the app. And, people are doing this. I mean, yeah, and I think that's a real positive sign because it means that this data is that valuable that it's actually worth this expense and this effort and this pain that organizations are putting in it today. So that's, I think the good sign for where we think things ultimately have to go is this proves the data is that valuable. But of course, we're left with a pretty fragile system. We're left typically with copy after copy after copy, because even after we made that first copy, every use case that a different team, has for that data, they want to transform it or wrap different semantics around the data. So we've got, obviously a lot of Python scripts laying around, and the whole system is quite brittle. So what's the first stage? The first stage is to have a more thoughtful approach to new systems. We're not going to replace how we've done things over the previous decades. That legacy is there. We're going to be living with that legacy for decades, even into the future. Dave talked about some interesting ways where you can still put layers on top or still bring that data into this new world. But we are building new apps, buying new apps at a rate faster than we've ever done in history. And one of the things we should be looking at is a very strong, I would argue the most important evaluation criteria, but certainly a very strong evaluation criteria is how usable is this data of this new app or thing we're building? How usable is it going to be to us in our organization? And of course, we're big fans of graph data and knowledge graphs in particular. So that would be an ideal state if we, we're able to go out and buy a ERP or a CRM system or whatever apps, and they all just sat on top of knowledge graphs. And in fact, the world that we talk about is one that I believe we'll eventually get to. I recognize it'll take time. But today, the way I describe it is what we do all day, every day is we send our data, this valuable thing, we send it to these apps. And if it's a SaaS app, it means we're basically sending it to another company. And we need to completely turn the model around where the apps come to the data. We control the strategic data and the apps come to them. And I'm excited to see, some relatively new, but some attempts. We just saw someone reach out to us recently that was looking to build a whole new ERP system on top of a knowledge graph. And while I don't know that a new entrant like that is going to displace something like an SAP overnight, I think that we need to see those types of activities. So if you're purchasing an ERP system and if you're thinking about your data very strategically, not that there's going to be a lot of options, ERP based on a knowledge graph, but I believe there will be more options over time. And so thinking about this in your purchasing decision is absolutely going to end up helping us get there. This third is, legacy erosion. So how do we end up taking some of this existing data, creating semantic mappings, kind of layering it into some of the models that Dave had talked about. And ultimately, we get to this legacy replacement vision. Now, we see this vision as decentralized domain data that can be seamlessly connected and queried, at runtime across an organization. So this is the world where I have all of these domains or pockets, maybe product data in one pocket, customer data in another pocket, whatever the case may be, but they can be virtualized as though they're one database. And of course, apps and new apps that are being built ultimately come to this data to not only read it, but be able to update it. And some important technology capabilities we think need to exist for this to happen. One is certainly knowledge graphs, which have traditionally been used more as an analytical platform. They need to be more operational and they need to have the ability to scale more. And that's an area that we focused a lot on. The second that I talked about, which is that the data smarts and importantly, the data permission and policy sits in the app. Well, to really exist in a world like this, we need to actually bring that data policy, data permissions into the data tier to make this really effective. So that's another big focus we have. And another kind of area that we've focused on innovating around the knowledge graph ecosystem is allowing time to be controlled. Because when you have all of these disparate data sources and they're all getting updated all the time, there's no way to have reproducible and predictable results unless you can wield time. Unless you can say, hey, I'm going to issue a query, it's going to go across this network, but I need to lock in a specific moment in time so I can reproduce those results. I know exactly what we're doing. So that's another area that we focused on that ultimately we think are going to be important building blocks on top of the existing technologies that we've seen historically to make this future a reality. So what is a good way of getting started in an organization down this path? So step 0, we call it here, is start with a tangible use case. So this term actually comes from Dave, think big, but start small. You need to think about how ultimately that double jeopardy board that Dave put up is going to come together for your organization. But I think one of the challenging things for a company is to feel like you got to figure all that out up front. And there's often tangible use cases that produce very high value returns that can be done, of course, in a relational system and maybe a bunch of Python scripts and stuff like that to stitch it together, but where in particular knowledge graphs excel. And I just, threw in this one example, a consumer packaged good use case where a large CPG provider has data coming in from all kinds of e-commerce channels at a very high speed, velocity of data coming in. And it is all relatively untrusted, certainly has no consistent semantics, everything's described differently. And they have a whole team of people who just tries to keep up with this. And here the approach is using a probabilistic approach in machine learning, be able to actually train machines and AI to be able to go in and figure out data on its own so that we have a scalable approach and we stop doing these one-off approaches. An example here is that across all of these systems, about 48% of records that did not that were duplicates of each other, although were not previously known to be duplicates, are identified. We're able to tag the products against the taxonomy or ontology that the client here wants, even though the data is coming from external sources they have little to no control over. Being able to enrich that data with additional attributes that are important for the business, and then being able to have a consistent mapping going forward of how we can consolidate this data together. So it's a simple example. This is a particular project. It didn't take a long time, but the results are very, very tangible, high accuracy, and by using machine learning, in this case, we're actually able to do a lot with very little effort. So we kind of run through these steps as model, map, consume, and then extend. So the first thing is let's create a model for data. There's a lot of vocabularies that can describe data. One thing that we have found as well, industries do put out certain vocabularies, like in EDMC Council, for example, you have FIBO for financial services, you have IDMP in the pharma side. These are extraordinarily detailed ontologies. And when you get into them at a very deep level, you understand why they're modeled the way they are. But they also, I think, for certain organizations that aren't used to working with them, can also create an obstacle because they look very complex. They're very difficult to get your hands into. And I think they create some friction in adoption. And I think it's important to note that if you're looking to, for example, represent financial data, and FIBO seems like a good idea, and it may be a good idea, or you're representing medicinal products and you're looking at IDMP or you're looking at SNOMED, those may be further and more detail than become necessary to solve some of these tangible use cases. And one of the things we found is, especially when we're automatically classifying data and organizing data for a business, that's often looks like a different taxonomy, a different way of modeling your data than some of these standards ontologies. And they can act as an intermediate step. So if I have a project like the project I just described in the CPG, I could go out and try and find a very complex CPG ontology, and that may be the right thing to do. Or I could just focus on solving the business problem, create the part of the ontology that makes sense for me and the business. And then the nice thing about this kind of domain and knowledge graphs is there's opportunities to map your ontology that makes the most sense for you and your company to some of these standards ontologies afterwards. You don't need to go all the way in. But anyway, the first step, of course, is, find the vocabulary that makes sense. Of course, Semantic Arts puts out the great GIST ontology, which works as kind of a high level, upper level ontology that can be extended for the concepts that make sense to you. Schema.org, we use that a lot of in examples just because people, especially with JSON-LD, which we focus a lot on, are used to seeing schema.org. But there's all kinds of vocabularies out there that can serve as inspiration, and getting the right business case mapped to the right model is the first step. Then mapping, how do we then take our existing data. If we're building something new, we don't have to do a lot of mapping. We're just building an app or a UI or a low-code, no-code interface like Dave talked about onto these models that we've developed. But if we have legacy data, we have this issue of how do we move this legacy data and represent it in this format. And of course, there's a lot of ETL tools and other tools out there, but they really go from relational to relational. And what we're really looking for here is a relational to graph sort of paradigm, and it's a different approach to it. This particular screenshot here, although I can tell it's a little bit fuzzy, here we've described our model on the left, which is what a customer looks like to this particular organization. These are the attributes and the fields that this organization feels are important in describing a customer. They're just typed in words that make sense to the business. And on the right, we have all these data sources that the organization has sitting in their data lakes and data warehouses. We've got SAP connected in here. We've got all of these different enterprise systems here on the right. And what's happened is a model has gone out and actually used reinforcement learning to identify customer data in all these systems, figure out how to traverse, joins across relational database tables, et cetera, and ultimately comes back with a probabilistic view of mapping of where all this data exists automatically. And this level of effort, of course, can be done without a tool like this. But again, it takes a lot of effort. It's a lot of custom scripts and custom writing to do this. And those custom scripts and writing become, of course, fragile over time. Once we have data in this very strategic format, of course, the ways we can use it become pretty exponential. We're showing an example here. This is in what we call Fluree Nexus, but this is a product we're launching at the end of the month, a web-based view where from a vocabulary that's important to your business, we're actually automatically identifying data sets, not only within your business, but even across partners or connections to your business that are using these vocabularies. And what you're able to do now is identify different data sitting in different places that can automatically be merged or combined with this data. Again, we're not having to do all these ETL processes at this point. All of this is just leverage you're getting on top of your data where you didn't really have that leverage before. Also, things like API management become much simpler in this model. If you have your data in this form, instead of creating more and more and more custom APIs to allow external systems access to your data, we already have, I think, one of the world's greatest APIs. We've had it for a long time. It's called a query, and people can structure a query however they want. They can actually structure the results of the query to bring it back in the format that they want. And you can ultimately get to a point where you have one API. Give us your query and we'll return the results you asked for. Now, this works only when you can actually embed policy and permission into the data tier, because oftentimes all of these custom APIs are not only creating new custom representations of data in these proprietary systems, but they're also trying to enforce security. They're rewriting the query based on who you are, or showing or not showing certain data. If we can embed this policy directly into that data tier, then we have one API that we don't have to maintain, that any API or sort of any way people want their data back can be described by them and by the application. So there's just all these points of leverage that start coming out once you're in the strategic format, and these are just a couple examples. And then, of course, from there, and once you've solved a tangible use case like that use case that I started out with, that was kind of packaged, it showed clear business results. You're starting to get buy-in, as Dave mentioned, as people see some of the results, the light bulbs go out. Of course, the opportunity there is to rinse and repeat, right? You start over, you start expanding and adding additional data sets, additional domains, additional vocabulary concepts. You can get more and more sophisticated in how you're representing ontologies to, again, just keep getting more and more and more of this leverage out of your data and your business as a whole. One thing, I was on the data engineering podcast not that long ago, and one of the challenges that came up as I was being asked questions about creating data products in JSON LD or data products and sort of knowledge graph, as opposed to data products and CSV files, for example. And talking about a lot of these concepts, the concept came up is like, well, yeah, but we can do this today. And I think I want to say, yeah, you can do this today. The word that kept getting used up is, well, we can just put in a semantic layer on top of the data warehouse or on top of the data lake. And then we can put a permission layer on top of it, and this layer and that layer. And I think that's the key word there, is we're building layers on top of layers on top of layers on top of layers to try and get some of this capability that requires no layers. And of course, the issue is once you're sitting on 3 or 4 of these layers that have been built up, you have no visibility into any layer that came before you, and any sort of issue or error or problem that could get introduced as in one of those deeper layers affects everything on top of it. So it can and it is all being done with other sorts of technologies. It's just coming at immense effort and immense expense. And for where we need to go and how we need to continue to more strategically leverage data, it's just not scalable. We need a better approach that's going to be able to make that happen. So with that, I will conclude. Oh, I just wanted to bring reference to, expanding data sets and expanding domains back to Dave's slide as far as his double jeopardy and how all of these additional sort of domains and concepts can exist out there. So we'll jump into questions. Before we do that, and some of you end up dropping off, I do want to say that we have these 3 opportunities for next steps. One is a data-centric assessment. So we're kind of positioning this as a brainstorming session, which we're happy to get on both Fluree and Semantic Arts to just talk about ideas, what you're doing within your organization, maybe different opportunities. There's a self-assessment that Semantic Arts has. The link is here. And the self-assessment allows you to go through just a self-directed assessment and get some ideas of opportunities for your business. I would encourage you to do that if you have an interest. And then Semantic Arts and Dave has been a real pioneer of this Data-Centric manifesto. And there's a link here for the Data-Centric manifesto. It's something that's worth at least reading. And if you're interested, you can sign on to the Data-Centric manifesto. So there's a few opportunities to kind of keep the journey going, keep in touch. And with that, I will turn it over to Kevin to see if we've had any questions come in.
Okay, yes, just a reminder to everyone, please put your questions in the chat or the question module. I do have one from Matthias. I think it's a really good one. Matthias says, I really want to get started with the knowledge graphs approach, but how can I do authorization? I have roles with overlapping domains, so ideally I need to be able to indicate a subgraph and say, this part of the graph, role A, can edit. Is there an ontology that can describe this? Is a shackle method an option?
We have, it's one of the things we've focused a lot of time and energy on at Fluree. I am not aware of other knowledge graphs that can embed the policy and permission into it like we do, although there's layers, of course, you can put on top of these things. Our approach has been to use some of the same concepts that Shackle uses and combine this with an area that you don't see a whole lot. I expect we'll see a lot more, but it's called relationship-based access control. And the use case that was just described there is a perfect example where you can actually use relationships in the data. If I'm connected to this data through some path, I can see it or I can modify it. If that connection doesn't exist, I can't. So if the data ever changes where that connection breaks, my permissions dynamically change. You can also do attribute-based and kind of role-based security as well, but leveraging relationships in that is a real opportunity. And then being able to target data by classes, as Shackle sort of gives us a nice template to do, is a convenient way of doing it. And if you are familiar with something like Shackle, of course, you don't have to learn anything new. You can target data by classes, or if, you can target nodes by if they have certain properties on them or they're pointed to by certain properties. So there's a lot of power and flexibility there. But ultimately, the goal is someone issues a query. That query is accompanied somehow with their identity. and that query is executed as their identity, which then is going to limit the amount of data that exists in their virtual graph and only return data that they can see. And I think Dave had a couple things to add, so I'll pass it over to him.
Great, thanks. No, that is absolutely right on what Brian said. I think the final correct solution is relation-based access control. Let me tell you a couple of things you can do in the short term that'll get you going, because this relation-based access control is a little tough both to get your head around and to get it implemented. What you can do in the short term, though, and we've seen some clients do this. Firstly, these graph databases all federate very nicely. You don't have to you don't have to co-locate everything. And in the act of federating it, most enterprises can say, I have some sensitive data. I'll put it in this graph and limit the permissions that can get to that. So if somebody attempts to federate over to that and doesn't have permission to that subgraph, it'll keep them out of there. The second level you can do is as we've done, is just construct your use cases such that the use case is smart enough to know. Now that's closer to role-based security, but you can get a long way with that. But then finally, when you're ready for it, the one thing I want to add to what Brian said, I think he said almost the two sides of this and didn't quite snap it together. In almost all graph-based applications, unlike in a traditional application, you've got an inventory control system and you're trying to think about how I do, attribute-based access control to the inventory. But if you're data-centric and you've got a system, you, the user, are a node in the graph. You're in there. You're in there as a user. You're in there as a person. We know what department you work for. We know which projects you manage. We know which people you manage. And as soon as you log in, we've got that node. So what Brian was saying, the relationship is you should be able to see things based on your relationship to it. You should be able to see your own social security number, even though it's PII, because you are related to it. You won't, if you're in payroll, you should be able to see the social security numbers of the people you're going to pay, because you have to do that in order to get people paid. But everyone else doesn't have one of those two privileged relationships to social security number, and they shouldn't see them.
Thanks, Dave. I have two for Brian, really rapid fire here on the Fluree system. Daralux asks, could it be fair to politely say that inheritance and subscription put aside, Fluree makes GraphQL effectively near irrelevant?
Well, I appreciate the question. I don't, people make a lot of technology choices for a lot of different reasons. One nice thing about GraphQL is it has a pretty robust ecosystem of tools out there and support out there, which is going to have advantages for certain people. But I think that, GraphQL is, we won't go into details here, but it is a layer, I'll use that word again, on top of typically relational systems that tries to stitch things together in a graph-like format to make it easier for APIs. And it's part of the solution. But when you natively are managing data in a graph way, many parts of that layer become unnecessary and other opportunities emerge.
Okay, one more question for Brian, and then I'll kick one over to Dave. Jose asks, how do you handle complex keys in Fluree? How about time-based, slow-changing dimension relationships, and do you support RDF 1.2?
I don't know that I actually fully understand the first part of that question. On RDF 1.2, so I'll focus on that part of it. Sort of we support it. So, RDF 1.2 really supports kind of attributions of assertions, and this is something we've natively done since the beginning at Fluree. Because we focus on keeping a record, a provenance of every data change over time, it means that every time we have a data change, we in effect have a new version of a database. We always link every version of the database to the data that has changed, the data that's been retracted or deleted in that version, and the new data that's been added in that version. And then we also embed additional metadata around how that change came to be. You can use some of your own metadata, but we always are attributing a timestamp to it. We're always attributing the identity of the user that changed it. So you can basically trace back every change, who made what change, who asserted it, and then also start to layer in your own, metadata. 1.2, I think, also introduces some things around like language, directional language. So if you're going to output data in a graph that's using language tags, is it right to left? Is it left to right? And a couple other kind of small things like that. That was kind of the long answer to RDF 1.2. Not 100%, but many of the most important concepts in RDF 1.2 are things that we've been doing in, I think, an even more sophisticated way since the beginning.
Excellent. For Dave and perhaps Brian to comment on.
Well,
can you mute yourself?
Actually, I was thinking.
Go on, Dave. Yeah.
Go on, Dave. I don't mean to make you echo there, Kevin, but let me just step in on the multi-part key thing, because I think what was going on there in a graph, there are no traditional keys or IDs that look like they do in relational, and therefore there's no multi-part keys. What there are globally unique identifiers that by best practice are based on HTTPS domain names. So every node in a graph has a unique identifier and doesn't need a join because it is globally unique. It joins itself as needed. So the equivalent of a subpart of a multi-part key is typically going to be another relationship. There's just another edge and another node that tells me, for instance, I don't know, what might have been a multi-part key for a project maybe was the sponsor. I'm just going to have a link to a sponsor. So it's a different way of kind of solving that same problem.
Thanks, Dave. Peter asks a great question. So Peter says, we've gotten ourselves into this software wasteland mess. Are there any sort of tools like scanners or maybe some new AI which could collect the full inventory of legacy data and metadata so that we don't have to spend time on these tedious tasks? In your first or second book, you mentioned this in a sort of inventory taking step. Certainly there must be some help here. Thanks, Peter.
Well, let me start it off so that Brian doesn't have to be too self-promoting. But Fluree has a tool that does this called Fluree Sense. There are other tools out there, so I don't want to give it like it's a monopoly or anything. But tools like Global ID, Big ID. We're starting to look at a few smaller ones. I've forgotten the names of them. But yeah, absolutely, the tools are out there, and I'm more and more thinking this is the right way to start. That just go out. We were just talking to somebody in a pharma company who's in the world of pharma. They have this that they call Data-Centric or something very similar to it. FAIR, findable, accessible, interoperable, and reusable data. But they want a scorecard to know how fair are we? What percent of our data is actually fair? And I think the only way to actually know that is first do an inventory and say, it looks like I have 100,000 entities in my various systems. How many of them are actually semantically known and mapped to a formal definition? And if anybody was honest about this, they would say, well, right now we're at 1/1000th of a percent, and our goal next year is to get to 2/1000ths of a percent. But I don't know if that would inspire anybody.
Brian, care to comment further?
No, I think Dave said that very well.
So we are at the top of the hour, so we're going to conclude this webinar. I just wanted to say a huge thanks to Dave and Semantic Arts for their wonderful partnership and especially for putting this event on with us today. You can visit them at semanticarts.com and you can visit Fluree at flur.ee. Thank you, everyone. Have a great day.